Morning, good afternoon, and good evening. My name is Kristen Robins. I lead the IT architecture team here at VMware.
Good morning, indeed. My name is Zachary Wang. I'm Director of Cloud Infrastructure Operations. Kristen will be the voice for us today, but I will try to make myself useful as well. If you have questions, type into the QA and button, and I will try my best to answer that.
So thank you for joining us on our journey here today. We're going to be talking today about a move of our production data center that was accomplished last year and all of the learnings that we had from that. So you might ask, what exactly what was it that we were moving and why move it? So three main areas I think we can talk about. One is all of VMware's primary websites. These are the ones that you're probably familiar with as a customer. These are the ones used for product information and support, blogs and communities, myvmware.com, vmware.com. Pretty important websites. Second is the Horizon virtual desktop system that we use as virtual pools for our customers or for our internal employees. These are essentially a way of having desktops internally. And the third, of course, is all of our main business systems, Oracle Business Suite, the Business Intelligence, Hadoop Big Data. This is essentially our cash register. The interesting part here, of course, is the eBusiness Suite is a 5-node Oracle rack database. It was over terabytes, 20 terabytes in size. So why move? There are lots of different reasons why one would move a data center. If you figure out that you need to be saving a little bit of money, if you've run out of room for your servers, if your air conditioning or chiller bills are getting a little bit high and they're not very good for the environment, if you need more power density, this is something that we see nowadays and really for the last 5 years with virtualization, where we're using these hungry servers, very power hungry servers. So very important to be able to get that power density that's not always available in older data centers. Going more environmental, right? Figuring out better ways of more environmentally conscious power. Increasing your power resiliency. This, with the new ways of having dual redundant power. There are newer ways of doing that. Getting better network connectivity, tech refreshes, right, is what you can wind up doing. So for us, it was mainly around lowering costs. But one note is really, if you can do this, you have to do a data center migration, let's say, make it an advantage and make it as part of a tech refresh so that finding CapEx is a little bit easier that way. And once you're done, your ongoing OpEx costs can potentially be less as well. So we had a number of guiding principles that we set up for the entire team when starting this out. First and foremost, we wanted to make sure that production services continued. This is an important part of our business. We didn't want to put this in jeopardy whatsoever. And ideally, no one would even notice that we'd ever migrated the data center if we did this right. Secondly, essentially we put in, as I mentioned, the resiliency that we needed. This is HA, backups, DR, essentially for the old data center. And of course, as part of that, we need resiliency along the way as we move from one data center to another. We didn't want to take any risks. And of course, cost reduction, right? So this was a main part of it. And of course, as is with most cost reduction measures, sometimes it requires a bit of upfront additional cost in order to get you to a better place. So we did have a number of approaches that we considered key to our success. The first was engagement and consensus, and this is a harder part for a lot of people where they're scratching their heads and they're wondering, okay, well, how actually are we going to do this data center? But it's the concept here is that you need to leverage your subject matter experts on this, have them understand the approach, have them agree to the approach, have them suggest different ways of the approach. You need to build, and a consensus is the best way to do this, is basically building that consensus through an interactive forums, through discussions, and a lot of times this can take quite a bit of time to actually get through, but it's well worth the effort up front. Secondly, strong program management. And this means, starting early, building in time for change freezes and setbacks, define your deliverables, and communicate well and often. Of course, this is have some type of mechanism where you do that, and drive the milestones. Right? If you have a schedule that you need to meet, it's really important to understand what that schedule looks like along the way, and try to meet those milestones. And informed execution was another third part of this, and so we had weekly meetings essentially around a lot of these, and we were tracking progress. We were monitoring critical resources along the way, and we were resolving issues as they arose. And make no mistake, no matter how much planning you do, there will always be issues that you'll wind up having to run into and figure out good ways around. So we also had a strategy that went along with our keys to our success, and that was, again, threefold. Practice makes perfect, right? Start with the simplest of migrations, right? You don't want to start with the hardest thing. So, and then kind of, gain understanding and gain experience with this as you go along the way. If you're a beginner in figure skating, it can really be a challenge to do your first bunny hop, of course, but then you're going to need to work your way up to those triple axels. Birds of a feather. So what this is meant to mean is if there are associated groups of applications or VMs within applications or groupings between applications and VMs, it kind of makes sense a lot of times to do those together. And the reason is they have a lot of these interdependencies will cause downtime. They will potentially need a high amount of bandwidth or storage. And those things would best be served if they're migrated together. And by the way, penguins have feathers. They lay eggs, and they are classified as flightless birds. I'll give you a little bit of fun stuff along the way here. No skating on thin ice. Okay, so don't take chances. And this is make sure your environment is safe, even in the middle of a migration, right? What you want to do when you do your migration is migrate your most important production applications at the same time as you migrate your network connectivity. So in case that you had a network failure for whatever reason, those might continue to work, right? And we'll talk a little bit about that later. This is a picture of Lake Louise. I had the luxury of being up there once and skating it was a better prepared rink than this. But it freezes over in the winter, and you get this absolutely wonderful place to visit. It's the Fairmont Hotel Chateau Lake Louise. And of course we don't get any perks from advertising these. Okay, layer 2 network extension. So we did a lot of preparation and of course between our data centers. And so what we did is we extended layer 2, and this is important from a if you choose to not re-IP, right? If you extend layer 2, you actually can do live migration and vMotion between data centers, especially if it's not too distant between data centers, but also if you use a tool that provides you the ability to increase your latency, and that would be like HCX. When you do your layer 2 extension, of course, your data centers might not be identical, and some VLAN numbering may need to be translated between the two sides. In our case, we had set up double resilience, right? So we, in addition to metro fiber, we were using internet over the top virtualization connectivity as a backup, so that in case metro fiber which was already redundant, would actually fail, then we still had internet OTV. So we were taking no chances here. And of course, HCX is a product that we'll talk a little bit about later. This has the ability to help and assist in a lot of different ways with respect to L2 extension, VLAN numbering translations, and essentially an over-the-top capability that allows you to extend WAN-like connectivity using just internet. So what were we doing along the way? It's pretty important to prepare your network. And one of the things that we did was to use our own tool, which is called vRealize Network Insight. This is part of one of our suites, vRealize Suite, I believe. And it allows you to do a number of things between VMs, in addition to doing NSX microsegmentation and whatnot. It's really good as a tool just to understand inter-VM and inter-application dependencies and flows. So we made good use of that, and that was really great for understanding clustering and dependencies between VMs. and of course the amount of bandwidth that's needed so that we could make those decisions around what would be migrated and when. Another piece of this, of course, is making sure that while you're doing the migration, it's really important to watch your bandwidth usage. If you were to run out of bandwidth, let's say you have normal bandwidth which goes between your two data centers, which allows VMs to speak with other VMs that are between two data centers. And you, of course, you're running vMotion potentially across these same links, or might not, depending how you structure your migration. If your bandwidth is maxed out, essentially your vMotion is going to fail and your applications potentially could fail. So make sure that we don't spike too high. Basically, most of the time it will continue running, but there is that danger. One of the other things that we had done, this was a chart that was put together by our project management team. They had their own view of the migration status. And so the idea here is to set your goal and say, okay, we're going to be migrating. And this was, you can see over here, this is a course of about 8 months or so, from June to February the following year, what the migration is tentatively going to look like. And the planned, migrations, of course, are interrupted by, of course, sales freezes and finance freezes. And so there are times when really nothing could be done, and you had to kind of hold on and wait. So it's important that when you do get those open windows, when you actually do a lot of migration. We did note that you can see here in the blue box, we had about a third of our VMs were actually decommissioned. So one of the things that gets done, of course, as part of this is you wind up discovering that there are some VMs and applications there that you might not remember through verbal history. You might not have a command database or a backup in your ticketing systems to understand exactly what these systems are. So what we did is we use what we call the scream test, and it's not really like a Hollywood screen test, it's a scream test. And the idea was you turn off the servers, you archive them, and you wait to see if somebody starts screaming. And in that case, the servers can be brought back and properly tracked and assigned to an owner. In our case, we only needed to bring back a single server. So, but we note here, I think the biggest thing here is there's actually a pretty good savings when you do a data center migration in the cleanup, the value of the cleanup. Another thing that, of course, we had was an internal dashboard for RAM monitoring and VM burndown. So this was an actual real-time graph. I'd say real-time is within a day, essentially. And it shows you the understanding of how much RAM you have in one data center, how much RAM you have in the other data center. And this is important from a VM perspective to say that, well, we have enough to accommodate what we will be using. And part of this, one of the things that contributes to this, of course, is reusing servers. There are instances when you have servers that are not quite ready to be decommissioned. You want to be able to bucketize that and have them show up in the other data center. We'll show a little chart on that later. So there are a lot of other little, I would say, simpler migration considerations. One thing to think about would be, of course, network services. These are things like DNS and NTP. And the idea here is as long as you have these services available on both sides when you do the migration, if it's could be the same IP, could be different IPs, however you like to plan that out, those will continue to be reachable during the migration. For load balancers, the idea here, of course, is to have a pair of different load balancers in the different data centers. You would essentially copy the VIP rules, the virtual IP rules, over to the new load balancer. You disable one or more pool members from the old load balancer, migrate it across, of course, and then put it in effect on the new load balancer. And you might want to do 1 or 2 or 3, depends on how many are in that pool. And of course, you can now turn off the old VIP, turn on the new VIP, and now the VMs that were being used in the old data center will now be serviced from the new data center. And at that point, you can migrate across the rest of the pool members. So no downtime. This is there's a some small amount, like microseconds or milliseconds sometimes, for just changing over the VIPs, but it's a very effective way to do that. Non-portable IP space is a big one. So as many people are familiar with the ability to do SaaS services, the idea here is that within your data center, you might have a number of VMs that are accessing SaaS applications. And sometimes it's important to be able to have the same and retain the same IP. So if you're let's just give you a little overview of portable versus non-portable. Not everybody knows about this, so we'll just kind of jump into a little mini deep dive here. So IP space in general refers to a network subnet, and in IPv4, there are local IP spaces which are not routed. These are typically known as RFC 1918 spaces. These are the supernets that you probably are familiar with, like 10/8, 172.16/12, 192.16/16. And since they're not routed, all the other spaces, in fact, are for the most part, right? There are some exceptions in the 10/8 space. So the way this works is the owners of the subnets, essentially for the ones that are routed, they advertise reachability to their network space using BGP. The RIRs, which are the regional internet registries, such as ARIN in the United States or the American Registry of Internet Numbers, they're responsible for keeping track of IP space ownership. And what's typically done, when you get a provider and you're using a provider, and this would be like a data center provider, right? They buy their own supernets and they advertise their own reachability, and then they sublet these same smaller static subnets of those to their customers, and then the customer doesn't really have to worry about all the rigmarole, right? All the extra effort to maintain their own BGP routing, etc. So it's actually it makes things quite easier for customers. But the problem with this, of course, is that the customers do not own these subnets, right? And they can't take them with them, right? If it's the same provider, the same data center provider, sometimes you can do that, right? But if you're moving to a different data center owner, really what you'd like to do is start considering using your own subnets. And essentially, you can go out and buy a subnet. I forget I don't know exactly what the current cost was. Years ago, it was anywhere between $1,000 and $4,000 for a year or something like that. But the idea here is that you'll take that subnet and you'll advertise it to the provider, which then advertises out to the larger internet. This is a really intriguing way to actually do DR, because you can actually advertise the subnet from multiple network providers, right, for HA purposes, or you could even advertise it for more than one location for DR purposes, right? So there's a lot of value in potentially owning your own network subnet and having that, and that's called portable space, right, because you can port it and move it between things. So that's what non-portable IP space refers to. And so why is this important, right? The concept here is that if you have set up we'll talk a little bit more about this later, but if you have set up a contract with a SaaS provider, and you have, for security purposes, let's say, have asked them to only limit traffic to a particular source IP. If you don't own that IP when you move the data center, that's going to cause problems. So we'll talk about, again, a little bit more about that later. Subnet and VLAN collisions may require renumbering, right? So this is something when especially if it's part of an acquisition, right? If you acquired a company and you bring in another company, they may be using the same IP space, and so it's possible you might also need to re-IP in that particular case. Physical appliances, it's really important to keep inventories, right? But when possible, a lot of these physical appliances have an HA component to them. So they'll have like a master, or I should say a primary and a secondary. And the primaries and secondaries, you could fail over, so the primary can become secondary. So what you could do is you could migrate the secondary, fail over to the secondary in the new data center, fail the primary, and then bring that over. And so essentially you have HA and very little downtime. One of the things that we did during our migration, of course, is to make sure that we wanted to minimize cost, and so backup was one of the considerations. We have a feature called Site Recovery Manager, and it actually has a multi-site option, which allows us essentially to use the same set of DR hardware on from two different data centers. And so what happens is we can use the same SRM pool that we had in our DR site and our disaster recovery site for the second data center. Now, one of the things that you notice is this potentially is kind of intriguing because this can be used as a migration mechanism itself. And in fact, we did use this in one particular case. We had some very expensive storage array for our Hadoop environment, and it wasn't quite ready for due for tech refresh. So we used SRM to fail over to the DR site and then move the storage array from the first data center to the new data center, and then reconfigured SRM essentially and failed back to the new data center. So that was actually used as a migration mechanism. We'll say a little bit about our migration tool of choice. There is a feature within vCenter. It's been there for quite some time. It's called Cross vCenter vMotion. And what this allows you to do is to migrate servers, or VMs rather, between different vCenter controlled clusters and essentially perform a non-disruptive migration. So this is a live vMotion between vCenters. Now this is important, of course, is if you're creating new vCenters in the new data center, that's usually best practice because the re-IPing vCenter can be intriguing and troubling sometimes. So providing new vCenters, of course, is a good way to do that, and migrating between them is great. The other thing, of course, is there's a minimal of additional configuration. It's fairly easy to do. Right now, it is a command line implementation, and there is a UI that's available via a Fling, a VMware Fling. These are essentially an unsupported capability that can be added to vCenter products, but usually they're pretty robust. And this is known as the Cross vCenter Workload Migration Utility. We will note that it would be great if they built this into the product. I don't have any information on that, but it's a really great tool. So take a look at that. Usually done by scripting, and Zagwe on the call here did a lot of that. Now, one of the things we talked about a little bit earlier was HCX. And what HCX is it's essentially an enabler for long distance migrations. It's a unique tool in this space. When we talk about migration too, it's not necessarily data center to data center. We could also be talking about data center to cloud, cloud to cloud, cloud to data center, right? So all these kinds of capabilities are still available in most places. You just have to create the necessary infrastructure. So HCX consists of a number of different components. There's a manager that actually controls the entire migration, has the ability to do scheduling. There's an HCX interconnect piece, which essentially secures the communications. If you wanted to run a migration across an internet, essentially what this does is it's similar to our VeloCloud product in some ways, but it runs essentially an IPsec tunnel between the two sides and provides the L2 extensions across in that fashion. What's important, of course, is that in order to do some level of TCP optimization and allow your bandwidth to run full throttle essentially across a long distance, there's an HCX WAN optimization component. And the way this works is, I think if people are familiar with the way TCP works, where you have ACK NAC after roughly 3 packets, you'd send out 3 packets, you'll wait for an ACK or an ACK, and ACK you'd have to retransmit, an ACK you'd actually go ahead with the next 3 packets. The longer the latency is between the transmission and the resulting reply to say to continue the transmission, the slower the transmission will go, right? Because you're winding up waiting a lot. You do a lot of waiting. So what HCX WAN optimization does is essentially TCP optimization that allows you to locally proxy the ACK-NAC capability to speed up normal network transfers on your, especially vMotion, right, is important, but others as well. So essentially this gives you the ability to optimize your links to get them up to high speed, even though you're going along a distance. And of course, the L2 network extension, as we mentioned, you don't need to re-IP, right? So you'll have the ability to essentially extend these layer 2s between the two sites. VMs can even on the same subnet. The same subnet exists on both sides. You can migrate one of your VMs in a set that normally would talk to another VM. Of course, now it can talk between data centers with that L2 extension. So not everything was roses here. So we had a weird problem that we ran into, and what this was there were a number of virtual machines. Some of them were virtual appliances, and we would migrate them to the new data center, or try to, but the migration process would fail when it hit about 72%. And we were scratching our heads. We called up our global support systems to try to see if they had any information on that. Nobody seemed to know what this was. We managed to, it was a casual hallway conversation with one of the team members who was working on the issue, and he recalled seeing this like years back. And he said there was a problem with a virtual disk being an odd size that's preventing the migration from succeeding. And all you have to do is essentially resize the disk up to the next highest integer number. And in fact, that was the problem. It's kind of surprising. And we don't know how this disk size actually occurred. But if you guys run into this problem, this is the way to fix that. Basically, just bump it up to the next largest size. You just enter it in the value here. So this case, you would use 1229, and you're good to go. vMotion will work after that. Anyway. Okay, so we talked a little bit about optimizing budget before, and this was around reusing some of the assets that we had. In the case that we have them sort of color-coded here. So the servers highlighted in green represent those servers that, these are fairly new. We don't want to, they're still good, maybe a couple of years old. And the ones in blue, well, maybe they're reaching their end of life. And so what we wanted to do is be able to bucketize that between data centers. So we would move over first we would add a couple of different servers to extra seed capacity, essentially to provide capacity within the data center for migrating the VMs. We would migrate then some of the VMs over into the new space. We'd then be able to migrate some of the servers across, some of the green servers, and then eventually bring all the workloads across. Now, one of the things, of course, that you had to address was constraints around licensing. In order to optimize your licensing, you might have different clusters that are specifically designed for size, to say we want to limit the size of this cluster so that we're not paying overly for a number of different licensing requirements. One of the challenges we came across was NSX and migrating between data centers. NSX itself works great. We show NSX-V here today. This does also work with NSX-T. We were using NSX-V at the time. This was last year. And so what happens is the way NSX is typically set up for microsegmentation is you define which apps can talk to which other apps, potentially on the same layer too. In terms of sometimes the app names, sometimes you use a metadata field that's present in vCenter on the app itself, and say this app, like for instance, the front end web server can talk to the application, and maybe the application can talk to the database, etc. So those rules, they're very common. But the problem is when you stretch between data centers with two different NSX implementations, that those rules and policies, even if you copy them across, they don't understand source IPs, right? So what we did is we worked with the NSX team to create a special, I would say a script probably, to modify these rules to add IP sets. And what this does, it says not only do you have these microsegmentation rules which are listed as metadata, but you also have them now in terms of IP. So IP XYZ can talk to IP ZABC or something like that. So we copied those across, duplicated these augmented rules, and then you could migrate the apps because the policies were based on IPs. And so now, even though you might not have the metadata from a VM over here, you can make decisions based on a policy which is IP based once it comes into your data center. So you're able to determine whether those two can talk. And of course, once you're completed with your data center migration, then you can modify those rules back to say name and metadata only. You'll be done with the first data center, and on you go with life. You're successful there. So, so let me talk a little bit about our network migration strategy. There were a couple of different choices here, right? Many folks said, hey, let's do this VLAN by VLAN. So we're going to migrate over. The idea here is we'll migrate the VLANs themselves. So this is the network connectivity themselves. We'll migrate those across, and we'll change the gateway, of course, to be the new data center, while you have some of the other gateways on the first data center. At some point, you change your portable space reachability. This is your network portable space that we talked about earlier, and then migrate over the rest of the gateways. Now, that's one way to do this. The other way, of course, is to use a big bang approach. And the idea here is everything moves at once. So it's a little scary. It is definitely riskier. It's kind of like an all or none. I mean, you do have the ability to revert fairly easily. You know, just boom, you migrate it back, change it to the other side. But let's just talk about the issues that are with a VLAN by VLAN migration. So we talked earlier about the SaaS provider whitelists and the ACLs that potentially could be put into place, access control lists. If you have a VM and it's at your first data center, and it's used to talking, it goes through a network address translation, typically from that changes it from an internal space, you know, one of the 10/8 spaces, into, let's say, an external IP of, we'll call it 1.1.1.1, and your SaaS cloud service that you're using has a rule to say, I'm going to permit 1.1.1.1. Of course, when you talk to it, everything is okay, and your traffic works. However, let's say now we move the VM to the new data center, and you get a different NAT pool, and essentially you have a different external IP. If you do this, of course, this is blocked, and you need to contact the SaaS cloud service provider to say, hey, you need to let 2.2.2.2 in also. So there's a lot of planning up front, right, to make this happen. Once they add that in, of course, then everything works as expected. So you really don't want to have this happen where you have an outage. And the planning that you need to do essentially is you need to research essentially all of your outbound SaaS connections. You need to contact the SaaS service provider through whoever is the owner, the relationship owner within the company. Usually they'll reach out to them and say, hey, you need to add in 2.2.2.2. And then we're going to do a migration, and then afterwards we'll clean it up and we'll get rid of the 1.1.1.1. But in any case, you can see this is going to need a bit of discovery sometimes, because a lot of things get changed along the way. Not everybody has a list of which SaaS providers they've reached out to and what ACLs they have in place. If by the way, on the previous slide, if you have a portable network subnet, maybe that's not an issue. So second policy, the second problem here is essentially, let's say you have VMs within a data center, and there's a firewall policy that allows or disallows traffic between them. Of course, you're going to need a new firewall in the other data center, and of course, you copy over the firewall into the new data center. But as you migrate a single VM, let's say, and you have these VMs talking to each other, now your stateful policy that you used to have in the firewall is split between two different firewalls. And maybe you need to create some type of transit zone that goes between the new data center. And then maybe you need to change the policy somewhat. And of course, you need to create new zones because, well, the transit zone is its own zone. And this gets quite complicated and rather fragile. So what we decided is this is probably better done. Let's not do that, essentially. So overall, what we determined is if we do a big bang approach, this is essentially wins, because the VLAN by VLAN, it creates problems in the SaaS providers, ACLs. It creates problems in the firewall policy changes that make the changes fairly fragile. Ideally, what you'd like to do is with a firewall policy is copy over everything exactly as you have it, and you have no problems thereafter. If you're changing IPs, you'll have to modify the firewall policies to accommodate the new IPs, of course, but it's relatively a small effort in comparison to redoing the policies. So we're kind of wrapping up here a little bit. Give you a couple of interesting other little notes. What we've learned, okay, so plan well. Engage your team, engage your subject matter experts, come up with an efficient plan. make everybody agree to the roadmap and how things are going to go across. Make sure you get all your long lead items taken care of up front. Sometimes that's buying or configuring or installing new equipment. Recognize that new is not always better, right? We had a number of challenges with 25 gig internet, which was fairly new, like as of 2 years ago. We actually worked with the provider. It turns out to be somewhat of a driver issue that was done by the NIC provider. There are challenges, right? So if you do a migration, and especially if you have milestones you need to meet, sometimes make sure that you either do a really significant POC or you use known good hardware, right? So it's always helpful. There is a migration tool that's available for NSXV to NSXT that can assist in the NSX migration as well. So I think everyone's heard of Gordon Moore, and Moore's law. So with the doubling of capacity and whatnot every few years, every year and a half, 2 years. We had a picture of what a difference 5 years can make from a technology standpoint, and essentially what our block storage looked like in the old data center. So we had 2 EMC VMAX arrays, we had a few VNX arrays, and 2 vPlex storage virtualization appliances as part of this. They had a combination of SSD, hard disk, and of course we're using FastVP to dynamically promote and demote blocks of data. This is multi-tiered storage essentially. This was all due for a tech refresh. And so any guess on, I don't know if people can guess this, what do you think? Would we cut the storage in half or a quarter? We actually went to about 1/8 of the size, less than 1/8 of the rack space. 17 cabinets down to 2, and of the 2, they were only half full with equipment. We had vSAN to help out. We also had standalone servers in the data center as well. So it's not like these weren't vSAN capable. From a data center perspective, we're looking only at storage cabinets. If we show the server numbers, there's also a significant reduction, but it is a little bit less than this. The storage was really quite amazing. So the outcome, we also added vSAN, by the way. Yeah. So the outcome is that we migrated 4,000 VMs, moved between 2 data centers with over 300 critical applications involved, with 4 petabytes of data. Now, some of this was done offline. We would ship servers across and things like that, but a lot of it was done online. We had a 3-to-1 reduction in rack space and power overall, and there were essentially 4 hours of downtime. And project was completed in less than 12 months. So the 4 hours of downtime, I'll even drill down a little further that our network team, when we did the big bang cutover, they did a marvelous job of rehearsing and getting that all right. It wound up only taking them 1 hour. There was a little frantic period in between as the routing changed a little bit, but that was done within an hour. And then the other 3 hours of downtime was actually used for some database upgrades that were needed along the way. So rather than take a downtime, they just did that at the same time as the migration. So that was pretty impressive. Power was reduced from nearly 1 megawatt to about 1/3 of that. And I have to say, I'm really impressed with what we could accomplish with a lot of the products created by the teams here at VMware. Very an astounding capacity that we able to do. Lots of features within the products that helped along the way, and great support that we got, of course, when we needed it. So I hope you enjoyed hearing about some of our VMware products so that we could pick apart some of the application dependencies and do essentially a seamless migration, all while maintaining critical uptime. So I'll move at this point to questions. Zagwe, do we have any questions on the call?
I did answer a few questions in the QA section. There's one question, Kristen, regarding what kind of inventory tool we use to monitor our progress, to assess our availability of compute resources along the way. Can you share some detail? of the tool we use?
I can. Let me see if I can step back to that slide. But essentially, it was an in-house tool that we built in order to keep track of inventories within the various vCenters. I think we announced externally that was potentially a new tool that we are moving towards potentially productizing called Clear Sky. And that's something that's still in the works. And that's about all I can say about that, really. But it's you can do your own in-house tool essentially and build inventories of and counts of VMs along the way.
Yeah, so basically the tool we
APIs.
use, basically, yeah, is completely based on the vSphere API, right? We basically use an API to pull all the VCs you have in your environment and present them together, right, under the single pane of glass.
That's right.
So, yeah.
Any other questions? Happy to answer anything you have.
So guys, feel free to type in the QA section. Okay, so Ankush has a question. How did we manage different array in SRM? If I follow correctly, we perform the failover and protect the VM and move the DC. If I'm not wrong, SRM support a single array. No, let me see if I understand the question. I mean, in our migration, actually, we had multiple array for sure. We have Extreme IO, we have the array we talk about for Hadoop, and then we also have vSAN space. So SR does not have issue with multiple arrays at all, right? It's just a matter of for you to create consistency group, create a recover plan, and create recover group RP. Yeah. So that's really just a matter of you configure on client side to accommodate different consistent groups.
Yeah, SRM has I think it's specifically called a multi-site option.
Yeah.
That enables this capability.
And the other question just came in. How can we repurpose the old data center to store large data set using the big data and Hadoop? How can we repurpose the old data centers?
So you could, yeah, go ahead, Zagwe, I'll let you take that.
Yeah. So in our case, we're not repurposing the old data center, right, Kristen? We basically moving out and our contract expired. What's your perspective on that?
Also, I mean, you can reuse the existing equipment. You can certainly reinitialize, reconfigure it to do that as needed. Not sure what the question is asking. Could you be more specific?
Yeah, so I don't know if they can speak up. Arjun, yeah, if you have more detail, you definitely type that out. How are we repurposing the old data set? So you're talking about application data now, right? I assume you're not talking about the hardware. You're not talking about the virtualized environment. So storage space, yeah, if you have old storage array, in our case, we do actually, we repurpose in other environment. For example, engineering test labs, right? If they require scratch space, you can definitely repurpose those there. If those array already expired on their warranty, not supported anymore, right? So if they still have good life left in them, as Kristen showed, we basically play a music chair, right? We migrate data off, and when they are not in production anymore, we move the array and redeploy them if they still have good life. Any other questions?
Okay, let's move this along. If you have any other questions, you can feel free to type them into the box and we can still try to answer them. I just want to point out a little bit about our VMware on VMware program resources. We have 4 ways to reach that. The first is email. And this is, of course, VMware using VMware. This is what we're all about with this program and with this outreach today. Second is the blogs. Actually, this is an interesting list of again, the presentations that we do make, and of course more notes on each of those and how that works. The third is the VMware program. It's a little bit about the program, and if you want to reach us on Twitter, there's a fourth link there as well.